In this video, we're going to cover the trigonometric form of a complex number, so the trig form of a complex number. So if you're working with powers and roots of complex numbers, so like if we had something like this, or something like this, it would be much easier to work with it in trigonometric form. So I'm going to say that we have a circle, good enough. Call that a unit circle. Now I'm going to say that this is my complex number. And as you can notice, when I go out to that complex number from the origin, so the distance, it's going to create an angle. And this angle is theta. This right here is r. That's the radius of the circle, so that would be length. This is going to form a triangle. This is going to be your A, your real part. This is going to be your B, your imaginary part. I and R. So you'll notice that we can write A equals R cosine theta, right? So it's going to be cosine theta, and then since the circle is bigger than the unit circle, it's going to be multiplied by this length to scale it. So it's whatever the unit circle measure is scaled to this length. You can do the same for B, which is in the sine direction. And that's because this one would be your X and this one would be your Y. R is going to equal A squared plus B squared, square root of that. And that's distance. Remember, that's your distance formula, or the absolute value of your complex number. So you'll be able to find theta by tangent theta equals B over A. And you'll have to take the inverse also. So if Z equals A plus BI, but A equals R cosine theta, and B equals R sine theta, I, notice that we're going to have Z, the same complex number, is equal to R times cosine theta plus I sine theta. And we can bring that R because it's a part of both of them. Now, this is called the trigonometric form, but another form that you'll be much more familiar with later is polar form. So that's what this is. That's probably how you'll know it if you get into math or engineering or something like that. Now, writing a complex number in trigonometric form. So we've got A equals R cosine theta, B equals R sine theta, R is equal to the square root of A squared plus B squared, and tangent theta is equal to B over A. So A, we're going to need R for these. So let's find R first. So our A in this number is 0, because A represents the real part, and there is no real part. This is purely imaginary. So your B is going to equal -2. We don't include that I when we write B. So that means that R is going to equal 0 squared plus -2 squared. It's going to be square root of 4. So R can't be negative. That's why it cannot be -2. It's got to be positive. What does a negative radius even mean? It's like sucking backwards and on itself, like a black hole of a circle. I'm not quite sure. I mean, it'd definitely be bizarre to try to imagine like a mathematical belly button. So anyways, we found r. So now we've got 2 cosine theta is 2 sine theta. Our r is 2. Now notice we're going to have to use a different method to find our theta, because what we end up getting is negative 2 over 0, which it's like, oh my gosh, you guys can't do that. That would be not a good direction to go. So we can't do that at all. So what we're going to do is we're going to go ahead and graph this thing. So we're going to have negative 2i. So it's going to be right here. And we know that when we have a circle, that these guys are values of 90. So 90 degrees, 180 degrees, 270 degrees, and then this is your 360 degrees, or 0 degrees, depending on if you're coming or going. So therefore, A is 2 times the cosine of 270. B equals 2 times the sine of 270. Remember, our formula is our cosine 270 plus I sine 270. And I'm going to put a 2 in right here, since we know our r. So you could build it one of 2 ways. You could go this way or this way. If we keep going this way, we would say a plus bi is equal to 2 cosine 270 plus I 2 sine 270, which, as you could see, they're the same thing. So what's the cosine of 270? 0. What is the sine of 270? Negative 1. Oh, by the way, this is your answer. But if you look, if we keep going to show that this is the correct number, we would get z equals 2, 0, plus negative 1i is equal to 2 minus I, or times negative I, which is negative 2i, which is our original number. So note these are the same thing. Please don't write it like this. They'll want you to take out that 2 and write it like this so that it is in the other form. But notice you'll get the same answer either way. Okay, write the complex number in trigonometric form. So we are going to take a is equal to negative 2, b is equal to negative 2 square root 3, and I'm just taking these guys. This is a, and that's b. So the tangent of theta is equal to a over b, and I'm just going to do a quick little sketch over here of where this number would be. So it would be at negative 2, and then negative 2 times the square root of 3. It's about right here. This would be somewhere down here. So that's going to mean that tangent of theta is equal to b over a. Sorry about that, guys. negative 2, square root of 3 over negative 2. These are going to cancel out, so tangent theta is going to equal the square root of 3. So in your calculator, you'll do second tangent, which brings up the tangent inverse function. Type in square root of 3. Make sure you have it in degrees. Usually that's easiest for people to deal with. So 60 degrees. If you prefer radians, go right ahead. But degrees would be ideal. So theta is 60 degrees. But notice that when we go over to our circle, 60 degrees is right here. That is not at all in the correct quadrant, because notice our A and B are both negative, so they're going to be in this quadrant somewhere. So that means I'm going to do 60 degrees plus, we've got 180, because it's going to make a straight line across, right? So it's 240 degrees. So that's the angle we're looking for, 240. Which means that in trigonometric form, we have, oh, we didn't calculate r. Remember, r is the square root of a squared b squared. Okay, that gives us 4 plus 2 times 2 is 4 times what is on the inside is 4 plus 12. So that's 16. That's 4. So r is 4. Cosine 240 plus I sine 240. And that's how you write that in trigonometric form. So here's a question where you are given a complex number in trigonometric form, and I want you to write it in standard form. So cosine of negative pi over 3, we're going to figure out these guys first, is equal to, and if you don't like radians, you can convert this to degrees. I'll do that over here, negative pi over 3 times 180 over pi. And remember, pi is on bottom because I want to get rid of it. That's negative 180 over 3, which is negative 60 degrees. So negative 60 degrees gives us a cosine of half. Pi over 3 is also half. So then sine of negative pi over 3 is square root 3 over 2. So that means we have got the square root of 8 times half plus the square root of 3 over 2i. And that's going to equal the square root of 8 over 2 plus the square root of 8 times the square root of 3 over 2i. So this is going to actually give me, and I will let you guys examine this one. So this is going to give me a square root of 2 plus, or no, this needs to be minus the square root of 6i.